Welcome to Clark Classroom. Please don't forget to subscribe to this channel. Let's look at this next example. Forces with magnitude 400 pounds and 200 pounds act on a machine part at angles 30 degrees and negative 45 degrees respectively with the x-axis. Find the magnitude and the direction of the resultant force. The first thing that we want to do here is to make a sketch of a diagram of the problem. So here we have force, 400 pound force above the x-axis at 30 degrees and the 200 pound force below the x-axis negative 45 degrees. And if we translate the 200 pound vector representing here the magnitude to that position, then our resultant force is going to be indicated here with R. So what we want to do here is resolve these two vectors, the 200 pounds and the 400 pound vector, into their x and y components, as we did in the previous example. So here we have the 400 pounds, that's the vector. And here are the two components, the x component and the y component. And since this angle is 30 degrees, then this side would be 400 times the sine of 30 degrees, which comes out to be 200 pounds. And this would be 400 times the cosine of 30 degrees, which comes out to be 346.41 pounds. And over here, note the direction of the 200 pound force. And this angle here is negative 45 degrees. 200 cos negative 45 degrees. And the y component is 200 sine negative 45 degrees. Notice that the y component is negative as the vector is going in the opposite direction from the positive y-axis. So we take these two values and now we combine them to give us the x component of the resultant force. So the x component of the resultant force would be these two pieces added together to give us 487.831. And the y components of those two vectors now added together. Notice that this is a negative component, so we do the subtraction here to give us 58.579 pounds. And now R will be equal to the square root of the x component square plus the y component square, and that comes out to be 491.34 pounds. So once you have your x component and your y component, you now apply the Pythagorean theorem to give you the resultant force R. And now the angle that we're looking for, angle theta, is the angle right here that is made between the x-axis and the y component would be like that. And the x component extend out to there. So this would be a combined x component, and that would be a y component. This is the angle here, theta, that we're looking for. So theta would be equal to the inverse tangent of the y component over the x component, and gives us a value of 6.85 degrees. We continue with the same problem But this time, we want to use the triangle of vectors in order to solve for the magnitude of the resultant force R and its direction theta. So, recall that these two angles together, 30 above and 45 below, gives me 75 degrees. And so the supplementary angle, which forms the obtuse angle in the triangle, is 105 degrees right there. So in our triangle, we have the 400-pound force, the 200-pound force, and this angle of 105 degrees that we are going to work with. So we apply the law of cosines to solve for R. The law of cosines tells me that a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of 105 degrees. And so we have here the law of cosines. We fill in those values, and the math tells me that when I work through these numbers, I end up with the square of R to be equal to 241,411. So R will be equal to the square root of that value, which comes out to be the same number we had before, which is 491.34 pounds. And now for the angle theta, we are going to be finding alpha, that's this angle here, first. And since this angle is equal to 30 degrees, what we will do is subtract the value of alpha from 30 degrees in order to obtain theta. So we apply the law of sines. A over sine A is equal to B over sine B. So here we have 200 over sine A comes out to be equal to 491.34 over the sine of 105 degrees. So sine of the angle alpha comes out to be equal to 200 times the sine of 105 divided by 491.34, and that comes out to be 0.3932. And so alpha will now be equal to the inverse sine of 0.3932, and that gives me 23.15 degrees. So alpha is equal to 23.15 degrees, and to get theta, I subtract that 23.15 degrees from 30 degrees to give me the answer for theta, which is 6.85 degrees. And these two results are the same results to what we had before. If you find this video useful, please subscribe to this channel, and I welcome your comments and or suggestions.